Hello student of class 8, once again I'm Sudhir and welcome back to my video, and today video I'll show the continuation of the exercise 15.3, and this video will show you the exercise and the solution of question number 2 of this exercise 15.3, okay, as the continuation of the previous video. And here I'm going to explain about the lessons at the end of this video, so please kindly uh, listen it properly, okay, what we have studied, what we have go through in this chapter about that related to our daily life and using of the graph, okay, where we can use the graph, what is the application of the graph, that I will tell you in the end of this video, so please kindly uh, listen it, okay. So here we go. We have the exercise 15.3 and question number 2. The question number 2 is asking us to draw a graph for the following. So let us see. Number one, number one, yes, this is the tabulation. Okay, this is the tabulation, and the tabulations you can see that side of the square in centimeter and the perimeter in centimeter. Okay, it's given here. So here the perimeter is given in centimeter, the side of the square is in centimeter. So what happened? 1, 2, 3, 4, 5 columns. You can see that it's giving that the 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 length of the side of square in centimeters. Okay, if it is the side is 2, then the perimeter is 8. If the side of the square is 3, then 12. This is given here. Okay, then you can see that the length, when the length of the side of square is increases, then the perimeter is also increases. You can see below here, isn't it? Yes, like from 8 to 12, 12 to 14, like this, as the side is increasing in length. Okay, so now we are going to plot this information or this data on the graph. Okay, so we are going to find out the points on the graph, so that points will indicates the value of x and value of y here. But what we will take here as the value of x is the side of the square, that is in centimeter, and perimeter will be the value of y. See, in the beginning, I have told you about the two variable, that is dependent variable and the uh, independent variable. So, independent variable will be taken as the value of x, and the dependent will be taken as the value of y. That you should remember. Okay. So let us see. The question is it a linear graph? We'll draw the graph. We'll plot this point on the graph, and we'll draw a line through passing through all the points. Okay, all these coordinates, and we'll find out whether the line is linear or not. Means whether graph is linear or not. Means linear graph means you know that it is of line, isn't it? So let us see whether it is line or not. Okay, so particular graph is this. Okay, so particular graph is this. So while I'm constructing the graph, you can see here start from 0, and we are taking its unit on the x-axis, okay, as 1 centimeter, its units as 1 centimeter. Okay, so unit 1, 2, 3, 4, 5, 6, up to 6 unit you are taking, because the highest uh, value of this side of the square is 6, so we have to take this. So these values are the independent value. Okay, independent value. So independent value have to be represented on x-axis. So x value will be or unit must be take up to 6 units. Okay, but how you make the units with 2 square or 1 square, it's up to you only. Okay, clear. And next you can find that the value of y, how we take the value of y, you see here. Yeah, here also it's 2 is the means its unit is uh, 1 centimeter. Okay, it's box. Okay, now you see here uh, why we take like this 4, 8, 12, the multiple of 4 here we take, isn't it? So each unit. Okay, actually here also let us see, in order to draw the graph, or in order to represent the given data graphically, we represent the side of square in centimeter on x-axis, and the perimeter in centimeter on y-axis. Then scale will take as 1 unit is equal to 1 centimeter on the x-axis and also y-axis. Okay. Then now we are going to plot the point here: 2, 8, 3, 12, 3.5, and 14, then 520 and 624. These are the coordinates of x and y. Okay, so we'll take this the side of the square, which is the independent variable. So this independent variable will be the value of x, and dependent variables, that is the perimeter. The value of perimeters are the dependent variables, so this will be taken as the value of y here. Okay, clear? So when the value of x is 2, then the y value will be 8, and 3 will be 12 as y, isn't it? So and so on. Okay, clear? So here you see first 2 and 8. So 2, the value of x2 here. From here you just come up and you'll take a point here, so that when you go towards the y you will get 8 here, isn't it? Yes. So this is a point to represent that coordinates 2, 8 here. And next 3 and 12. So 3 is here, then you just come straight up and you find a, you will get a point here, that if you go towards the y you will get 12 here. So this is the point here that will indicate the coordinates of x and y as 3 and 12 here. Okay, and next is 3.5. 3.5 is the middle of this 3 and 4, isn't it? So then 3.5, so if you just come up, then you get here. Yes, and then 14. 14 will be 12, 13, yeah, somewhere here, isn't it? Yes, 14, yeah, nearby this 16. So this is the point we take here. And then next is 6 and 20. So 6 you will get here, and then you can get here, this is the 20 here. So this is not a 5. Okay, this is this one. So 6 means you have to yeah, 6 you can see here, 6, 6, 5 and 20, sorry. Next is 5 and 20. 5 and 20, from 5. 5 is the value of x, and 20 is the value of y. Will be here, this point. Okay. So we'll take 1 point on it. And then 6 and 24. 6 is here, and now 24 is here, isn't it? So this is the point to represent the coordinates 6 and 24 here. Okay. The coordinates of y and x, that is 6 and 24 here. So then after we get these points on the locate all the points on the graph, then we'll join them with a line, single line. Okay, then it happens to be straight line here. If you find that it is straight line, then you have to say that join this point to obtain the required graph. Then what you get here, it is a linear graph. Yes, it is a linear graph. Means we get a line here, the graph is, so it is called linear graph. The line, if you get the graph as a line, a straight line, okay, without any bending, then it is called linear graph. Okay, then yes, it is a linear graph. Now let us see the next question. So we go to the next question. So next question, we have question number 2, but Roman number 2 we have. So in Roman number 2, so what is the tabulation given here? Let us see. Yeah, in the table is given here the side of the square in centimeter, and this side is the area of the square. If the side of the square is 2 centimeter, the area is 4. You know that 3, then 9, then 4 is 16. That you know, isn't it? The area of the uh, area of a square. There is square of the side, isn't it? Yes. So like this, we have this information in the form tabulation, and this tabulation you will find there the side of the square is still the independent value, and it is the value to be represented on x-axis, and area is the dependent value, and this dependent value is to represent on y-axis. You know now, isn't it? So now you clear that dependent are to represent on the y-axis, and independent will represent on x-axis, that you have to know. Therefore, the side of the square is the value of x, and the area is the value of y, and they will make the coordinates of x and y: 2, 4, 3, 9, 4, 6, so on. Okay, clear? So let us see. So it's also asking that is it a linear graph or not? Okay, clear. So let us see what is the graph of this particular uh, tabulation given here. So this is the graph of this particular tabulation given here. So you can see the graph here. All these areas are represented on the y-axis. Therefore, it come up to 36 units. Okay, and here 6 units are there. Yeah, so that it represents the size of the square on x-axis, isn't it? So when the side is 2, so what is the area of this square? 4 centimeter square. So 4 is here. So when you draw straight line from the 4 and another straight line from the 2, then these two will meet at this point. Okay. So we'll take this point, and this point will represent 2 and 4 here. Okay, clear? Yes. The coordinate 2 and 4. And next is 3 and 9. So 3 and 9 is here. You can see this is the point. Okay. So actually, I have shown here with the graph already been constructed or drawn with the line. But if you draw before joining, you have to find out the point first. Okay, with your help of a scale or some kind of dotted line and so on. Okay, clear. So the next coordinates are 3 and 9. So 3 is here of x, and 9 will be here a little above. Okay, so it should be a little above. So 3 9 here. Then next is 4 and 16. So when the value of x is 4, then the value of y is 16 here. We got it. Okay. So here 3 and 9 should be little above here. Okay, not half, but little away from the 8. Okay, in between this box only. And then next we have 5 and 25. So when you take the value of x5, then it will be 25 here. So 25 is here. Why? Because 25 will be little more than 24, but not half of this two. Okay, little lower the half. So we can take this point, doesn't matter. Okay, somewhere little above the 24, but below this, below the half of it. Okay, clear. Then next we have 6 and 36. So 6 is here and 36, you can see the top here 36. So this will be the point, this joining these two line of the 36 and 6 of x and y is the point to show the coordinate of 6 and 36. So after joining, you can see that we have to join this line. When you join this line, what happens, you will find that the line is becoming bending or being curved here. So if it is curved, then it is not a line graph. Okay, line graph must be a line segment or a continuous of line or unbreakable, unbroken lines. But this is not line, this is the curve here, isn't it? This is not a linear. Linear means straight line. Okay, so therefore this is not going to be a linear graph. Okay, so let us see. Yeah, it is not a linear graph. And then here I'll explain you about the definition of this graph. Okay. Now, in solution, in order to represent the given data graphically, we represent the side of the square in centimeter on x-axis and the area in centimeter square on y-axis. Scale is taken as a 1 unit equal to 1 centimeter on x-axis and the 1 unit is equal to 1 centimeter square on y-axis. So actually, this is not the perimeter. This is the area only. So here, this one written is little this one. So you have to rewrite this as the area in centimeter square, not perimeter. Okay, this one please carry it out. Actually, I copied from the. I continue the graph from the previous, so I forget to change this area in centimeter square. Please sense it. Okay, clear. Now next is that plot the point 2, 4, 3, 9, 4, 6. These points, these coordinates points are getting from, or the coordinates numbers are getting from this tabulation only, isn't it? So we have to plot these points on the graph here. So after plotting the graph, you can see that join these points and to obtain the graph here. But after joining the points, we obtain that the line is not a straight line, it is curved line, therefore it is not a linear graph. That's all. Okay, clear. So here we finish this question number 2 here, and also the last question of this exercise 15.3, and also the lesson or the chapter. Okay, my dear student. So my dear student, here I would like to tell you that we have completed our syllabus here, and now the next is to begin our revision classes. So revision classes, maybe sometime I will send you some working out in between, and also I may take live classes, or I may send some related small video clips also. Okay, clear. So that you please wait for this days to come for the revisions, and hereafter we are going to start revisions. Okay, so before we go, so let us see the lesson at a glance. Okay, now lesson at a glance. What we have studied, let us see graphically. The presentation of data is easier to understand. Why we need this graph is that we can understand easier the given informations. Okay, then a bar graph, you know that what is a bar graph? A bar graph is used to show comparison among the categories. Then a pie chart is used to compare the part of a wholes. Then a histogram is a bar graph, shows that data in intervals that you have to keep in your mind. And next, a line graph displays data that changes usually over periods of time. Then a line graph, which is whole unbroken line, is called a linear graph. So when you talk about linear graph, it should be a unbroken line, unbroken straight line. Okay, clear. Then for fixing a point on the graph, say we need x coordinates and y coordinates. Means two values we need. One value is of x, one value of y. So that points is called the coordinates. Okay, x coordinate and y coordinates. Two points are called. You'll locate a points in the graph or on the graph. That points will give you the value of x as well as value of y, and those values of x and y are known as coordinates. Next, the relation between the dependent variable and the independent variable is shown through a graph. Means by the hello graph you can see the relation, or you can show the relation of the dependent and independent variables, like that the amount money you brought and the amount of money that you borrow from your friend or from the uh, lender. Okay, and you give the interest. How much the interest is dependent on how much of the money you brought. Like this things is called dependent, and the dependent variables that can also be represented in graph. Okay, then uh, here we come to the end part of today's session. So thank you once again for joining me and watching this video. So we'll meet again in the next class. Till then, have a nice day, all of you, and take good care of yourself. And remember that, be aware of this pandemic, and don't go out, stay at home safety. Okay, clear. So bye bye, all of you. Thank you once again.